Solving differential equations by using and integrating factors. These are the calculation steps for you to solve the problem. First, you need to rearrange the differential equations given in the form of dy dx plus py equals to q. Based on the structure here, identify the p and q. Next, you integrate p over dx. Based on the outcome here, produce an integrating factors of e power of integrations of p dx. Next, you substitute this e power of integrations of p dx into these functions, which is known as the integrating factor. In the function here, there are y, p, and also q. Integrations of p dx is obtained from here, while the q is based on the structure here. Integrations of the function here will give you the solutions of the partial equations. If the boundary conditions are given, you are able to determine the constancy after the integrations. If you find this difficult to imagine, let us look at one example to demonstrate the calculation process. Given the function here, and the boundary conditions is x is equals to 0 when y is equals to 4. Write down the functions given. Rearrange it in the format of dy dx plus py equals to q. This will involve multiplications of this with x, and this with x, and this with x. This will give you these functions. Compare the structure here. You know that 4x is p and 2x is q. Your next step is to integrate the p over dx. The p you obtain is 4x. Integrating it, you get 2x squared. Now you have to produce the integrating factor e power of integrations of p dx. Integrations of p dx you obtain from here, which is equals to 2x squared, to be substituted into the function here. Substituting the integrations factor into the formula here. This will be substituted here, as well as here. The q which you obtained from the functions previously to be substituted here. This gives you these functions. Now you need to integrate these functions to find the solutions. It seems like there is a functions within the functions. Let u equals to 2x squared. Differentiate the u, you get 4x squared. Rearrange it so that one side have 2x dx, while the other side have 1 per 2 du. This 2x dx later will be used to replace by the 1 per 2 du here. Substitute the u and du into the function here. You will get this. Integrate these functions. You will get this. Remember to incorporate a constancy here. Now you need to replace back the u from the calculation previously. This gives you these functions. Go back to the original function here. Integrating this will give you this. After integrations, your new functions become this. With a given boundary conditions of x equals to 0 and y equals to 4, you will need to substitute those into the function here in order to obtain the constant c. Substitute the constant c into the functions, which will give you this. Rearrange the function here, you get your final solution.